Okay, good. So let's write down where you're up to at the moment. So 2 log of x plus log of 2 equals log of x plus log of 3, okay? So talk me through, what's the first thing you did? I've changed the questions, don't worry about that.
Log 2x squared.
Good, so you see the power climbs up there to become x squared times 2. All right. And then you times those two things together. Good, well done.
Then 2x squared equals 3x.
Good, you've got log of something equals log of something. Okay, so one temptation which people would have is just divide both sides by x. You see an x there, divide through by x. Never, ever do that, okay? So never, ever, ever divide by the thing which you're trying to find. You're trying to find x, so never divide by x, never just cancel x offs. The reason being, look at this power, okay? So look at this. Are you happy that because that is a power of 2, that means that you're looking for 2 solutions, okay? So if you just divide by x, you get 2x equals 3, which means x equals 1.5. Well, that's only one solution. You're looking for 2, okay? So what you should be doing instead is looking at this and going, I see an x squared. That's the highest power. By definition then, what type of equation is this? We've done loads of them. Begins with a Q. If you've seen x squared as the highest power, it is a quadratic. Does that make sense? Yeah. So because you've got the x squared there, it means it's quadratic. Now what do you do when you solve quadratic equations? What do you always make sure? What do you always do first?
2x squared minus 3x equals 0.
In other words, you set everything equal to 0. Fantastic. So whenever you see a quadratic equation that you're trying to solve, you always set it equal to 0. Good. So take the 3x on that side. Now you've got a couple of options for solving this. Of course, always when you're solving quadratic equations of this form, so it's always set equal to 0, you've always got the quadratic formula up the sleeve, okay? I would advise actually in this case you don't need to. You don't need to solve it. How would you go about doing it?
Like the normal one?
Yes, well no, how would you solve this equation? So you've got the quadratic formula, what other techniques have you got?
2 brackets.
Yes, in other words factorising, okay? So how would you factorise this? Can I give you maybe 30 seconds to have a look at that? See if we can factorise it. So I can see from your working from here, you've basically said, well, okay, this isn't quite an ordinary quadratic, because usually you need 3 terms, don't you? You've got your x squared term, you've got your x term, but then you're missing your constant term.
I put 0.
Perfect, well done. So yeah, so you put the 0 on the end. Let's think about that. So 2x squared minus 3x plus 0. Oops. Equals 0. Good, fantastic. So if we manage to get anywhere further from here.
2x squared minus 3x plus 0.
So you're looking, sorry?
2x squared minus 3x plus 0 equals 0.
I mean, I can't argue with that. Just remember, this is a non-monic quadratic. In other words, there's a 2 there. So in other words, you're looking for 2 numbers that multiply together to make something and add together to make something.
Multiply to get 0 and add to get -3.
Well done. So what did you find?
0 and multiply by -3.
Good, I agree with that. Okay. So in other words, I'm going to break this negative 3x into, well, the 2x squared is going to stay the same. The 0 is going to stay the same. So I'm going to break the negative 3x into 0x minus 3x. Oh, is that why you said minus 3x plus 0x? Okay, I'm with you now. Okay. Break it down the middle. What does this side factorise to?
I did negative first.
Did it the other way around? That's not a problem. I can change that over. Okay, so you put negative 3 there and 0 there. Okay, that's fine. So what does this side factorise to?
X bracket
Yep. And this side? You're going to need 2x minus 3 on that side, aren't you? So what you need to put there?
0.
Yeah, plus 0. Okay, so then what does this factorise to finally?
X plus 0 and 2x minus 3.
Good, well done. That's kind of it formally if you just want to follow the same method. Now, of course, if you're comfortable doing this, you might have noticed that up here, you could have factorised this directly. Because if you notice, x plus 0, that's just x. So I could just write this as x times 2x minus 3, which if you notice, that thing up there and that thing down there, it's just a straightforward linear factorisation. Well, not linear, I know, but just a straightforward one bracket. So it's up to you. You can go through that, or you can just see it directly. So what are your two values of x that you get out then?
X equals 0.
Yep.
And 3 over 2.
Perfect. Well done. Okay, so these are your two values of x. So x equals 0 or x equals 3 over 2. And that makes sense. I mean, you've got the x equals 3 over 2 if you just divide both sides by x. In actually this case, it doesn't matter, and I'll show you why in just a second. But yeah, there's also the x equals 0. That's your other solution as well. Okay. So these are my two solutions.
The 0 is cancelled.
Perfect. Well done. Because I need to make sure that I've got log of x, right? So I need to make sure that whatever I put into my log of x, in other words, x, that's got to be positive. So I have two solutions here. I've got x equals 0 and x equals 3 over 2. So I need to check that both of them are valid. But yeah, you're ahead of me there, so that's really good. So you need to make sure it's positive. Well, 0 is not positive, it's 0, right? And 3 over 2 is positive, so that's fine. So therefore, the only valid solution, so if you left your answer like this, you wouldn't get full marks. You need to say, this is not valid. And you need to justify why it's not valid. To be honest with you, if you write this kind of reasoning down on your page, I can see that, I can award you marks for that. If you choose not to write it down, you must say it's not valid because the log of x implies that x has got to be greater than 0. Okay, so always write down the reason why it's not valid. If you wanted to do this little table, that's fine. So you didn't need to do this and this. But either way, you need to say, so I've run out of space here, so I'll write it down here instead. So x equals 3 over 2 only. Okay, so that's the only solution that you're after. Okay, does that make sense? So it's pretty much, to be honest with you, the same kind of things we've been looking at before when we've looked at solving equations, right? It's just in this case, you'll just use laws of logs. Hopefully the laws of logs will only take you kind of a little bit further down. It's not going to be a long thing to have to do. But then, yeah, then once you solve it, it's not just a case of getting to there and thinking, great, I'm finished, I've done the job. Because you need to check whether it's valid or not. Okay, so always check that. Good, okay, so this one is slightly more tricky, do you agree? Okay, but I think it's just based on, it's just combining together skills which we've already looked at. So let's have a look. So you've got 2 log of x plus log of 5x squared minus 12 minus log of 2 equals log of 16. So what's the first thing you did here?
Log x squared.
Yep.
That's 5x squared minus 12.
Okay. Good, okay, so just break that down. So you first of all realise 2 log of x is x squared, log of x squared, but then you're adding log of 5x squared minus 12. So in total, you end up multiplying this log and this log things together. Okay, so you've got x squared times by 5x squared minus 12. And I think I heard you say that you've also noticed that you're subtracting this log, so you'll end up dividing that thing by 2. Good. So far so good, and on the right hand side you've still got log of 16. Okay, now what?
X squared log of 5x squared minus 12 over 2 equals 16.
Okay, good, so in other words you notice that is equal to that. So x squared times 5x squared minus 12, all divided by 2 equals 16, good.
And multiply 2 by 16.
Okay, so x squared times 5x squared minus 12 Perfect, well done.
Then 5x
To the-
power 4
Good.
negative 12x squared
Yep,
equals 32.
equals 32. So in other words, you distribute the x squared over the bracket. Good.
Then all equals 0.
Good. So you notice it kind of looks a bit like a quadratic, so absolutely make that equal to 0. Good, well done.
Then I got 5x to the power 4 negative 20x
Okay.
plus 8x negative 55.
Okay, so in other words, you're trying to solve it like a quadratic, isn't it? It's a hidden quadratic. Perfect. Did you make u equal x squared, or did you just go and do this automatically? So did you introduce another variable here, or did you just try and factorize this immediately? Okay, that's fine. Okay, so let's try and do it like that. Of course, you may want to make it easier by saying let u equal x squared. Then it becomes 5u squared minus 12u minus 32 equals 0. So it might be easier to see, but we're feeling brave, which I like. So, all right, fine. So you're looking for two numbers which multiply together to make 5 times negative 32. What did you get there?
20 and 8. Because 5 multiplied by 32 first.
So what was the 5 multiplied by 32? What was it?
160.
Negative, sorry.
160. Negative 160.
Yep. Okay, so they multiply together to make negative 160 and add together to make negative 12, right? So what did you got? You got 20 and...
Negative 20 and 8.
Thank you. Okay, so that's how you split up the negative 12x squared, is that right? So 5x to the 4. What came first?
Negative 20x plus 8x negative 50.
Of course. I mean, of course, it doesn't matter which way round you write those. I just want to make sure it's consistent with what you've got to make it easier for you. Okay, so how does this side factorize? Good.
X to power 3 minus 4
Okay, and on this side you're obviously going to need...
plus 8 and x.
Oh, that's squared, isn't it? Just remember that's still squared. So in other words, when you break this up, you're basically saying, look, I've got 5x to the power 4, that's fine. Then you're saying, okay, I've got negative 20 of the x squared now, plus 8 of the x squareds, minus 32 equals 0. So then when you break it down the middle, you factorize it slightly differently. So please make sure that you keep the x squared the same. It's no longer x because you're dealing with x squared there. Okay? So if you factorize this side, what do you get? 5
5x.
should be x squared, because you can factorize an x squared out of the x to the power 4 and an x squared out of the 20x squared.
Oh, okay.
Yeah?
X squared
Yep.
negative 4.
Good, fantastic. Let me just turn the lights back on. Okay, and obviously you're going to need the same on the right-hand side, aren't you? So you're going to need x squared
Plus 8.
minus 4 equals 0 here. Perfect. So you realise you factorise an 8 out of that thing. Okay, so in total, what have you got?
5x squared plus 8.
That's it. And the other bracket?
X squared negative 4.
Excellent. Well done.
And for the first one, x equals square root of negative 8 over 5.
All right, so let's break it down first of all. Let's just do one line in the middle. So you get x squared has got to be 5x squared plus 8 has got to be equal to 0, which means x squared has got to be equal to negative 8/5. Or, in this case, x squared has got to be equal to 4. Happy with that? Okay, so this thing here you said, well, okay, x has got to be equal to...
Square root of negative 8 over 5.
Good. And this one, x squared equals 4?
2.
Just 2?
Plus and minus.
Good, so make sure you capture the plus and minus as well. So have a look at this. Is this thing possible?
No.
So you can't, using the numbers which we're aware of, you can't take the square root of the negative. So you just say there's no solutions there. That's fine. Or no real solutions, I should say. Because there are solutions, it's just we don't look at them in this course. So make sure you put real in there. So I'll just put solutions for short. Okay. So in other words, the solutions we've got to go forward with are x equals plus 2 or x equals negative 2. So,
Negative 2 is not real.
yeah, excellent. So let's just make sure that we've written it down how we should. So let's just do a quick check for the benefit. So we've got two logarithms with unknowns. We've got this logarithm here. So we've got log of x. And we've got this logarithm here. So we've got log of 5x squared minus 12. That makes sense? So in other words, the two logarithms that we need to check are these two. For this logarithm, we're looking for x has got to be greater than 0, right? For this logarithm, what have we got to make sure?
Is it 2?
So 5x squared minus 12. So are you happy that when you check your logarithm, okay, you've got to check that the thing that you're putting into your logarithm, in other words, the thing inside the brackets, that's got to be positive, right? So in this case, x has got to be positive. With this case, the 5x squared minus 12 has got to be positive. Okay, so the thing which you're always putting in the logarithm has always got to be positive, okay? And then we have two x values to check. We've already ruled out these x values here, so we've got to check x is equal to plus or minus 2. So let's check first of all x is equal to positive 2, and then let's check x equals negative 2. All right, fine. So if we stick x equals positive 2 into this logarithm, the first logarithm, I'll call it logarithm 1 and logarithm 2, stick it into logarithm 1, is x positive? X equals 2. Yes. So we can stick a tick there. If we stick x equals negative 2 into this logarithm, is that positive? No, so put it across there. Okay, let's just check this in here as well, because it may well be that actually if we stick these things in here, it still doesn't come out as positive, so we'll still be in trouble. Okay, but if we stick x equals 2 into this, 5x squared minus 12, is that positive? So just think 5 times 2 squared, that's 5 times 4, which is 20. Take away 12,
Yeah.
that's 8, that's positive, that's all good, okay? If I stick negative 2 in here, is that positive?
Yeah, because
Go on.
it's a square.
Perfect.
Positive. That's
Good, so you just get negative times negative, so actually it's just the same as sticking 2 in there, isn't it? So you get negative 2 squared is just the same as 4. 5 times 4, 20 take away 12, that's 8. So that also works. So we've kind of got this little table going on here, okay? Now what I need to make sure is that whatever x value I use, it's got to work in both of these logarithms, so both this one and this one, okay? Now are you happy that x equals 2 works in both of those logarithms? So I know x equals 2 is a solution. But the issue is this one here does not work in both logarithms. It doesn't work in the first logarithm. So therefore I can rule that logarithm out. Okay? So I can say x equals 2 only. Okay? So again, you can either put a little statement at the end which says x equals negative 2 is not valid in log of x because x has got to be positive, okay? So therefore you can rule that solution out. Or you can just quite simply show me through this kind of table here that you've gone through that little check, so I can give you the marks for it, give you the benefit of the doubt, and I can give you x equals 2 only. If you don't put an explanation, if you don't put this table down, you won't get full marks. If you just put x equals 2 only without any justification for why you've ruled out negative 2, I can't give you the full marks. Yeah? Because are you happy as well that when you kind of get to this stage, so x squared equals 4, some people will just put x equals 2 down originally. I think you did it right at the very start, right? So if you just put x equals 2 down originally, well, yes, x is equal to 2, but you need to show me that it's also negative 2 as well. But negative 2 is not valid in our logarithms. Okay, so always put this down or put a little statement down, or both. But you need, either way, you need to justify why it's only x equals 2 to get full marks.